supervisor. So, can you remember the ER diagram of the employee? That is a self-reference sheet, supervision, right? If you see this is employee, then this is a supervision. Employee supervise, many supervising. This is a self, the relationship. It's the same thing. So I want to retrieve the employee's name and supervisor name. How many tables? So employee for what? Employee. Another one is employee for supervisor. You need to join two tables. But actually they are the same table. Right? So at the time you can use alias. So E means for employee. S means supervisor employee. There actually you access one table but as a two name, two ways. One is for employee, another one is supervisor. It's kind of the copy, virtual copy. Okay? At that time you don't have to type the employee E, employee S. This is called the alias. It's the name of the table, rename. Can you remember the rename? So, row. So rename. So employee SE, employee SS. Then E supervisor SSN is the same as S supervisor employee SSN. So join condition. So you can access the data. This is called alias. Alias will be used a lot. Why? Sometimes simplify. So, for example, employee, social supervisor, employee dot means the column. You can specify the column of specific name. Table name dot column name. So, employee dot super SSN. It's too long. So, why don't we use the alias E dot super SSN, S dot SSN. And another way of using alias simplify. Oh yes, simplify the name. Another one is because of the ambiguity of the column name. D name is in the department. D name, for example, name in the department, name in the employee, name in the everywhere. So you will be confused. So to avoid such a problem, we can rename the column name using alias. So for example here, EF name, ELN, SF name, SLN. EFM, E dot F name means F name, first name from the employee. S can be removed. It's optional. So S dot F name is, the first name is supervisor. So this is the alias. What if there's no where condition? Is it error? No, it's not error. As long as you have select and from, they are required. If you run this one without where condition, it will return all the data. What if the join employee and department without where? It will be Cartesian product. It will return all combination of employee and department. It's not join, it's a Cartesian product. Okay, what is the join operation? It's a Cartesian product plus selection condition. So, without selection condition, it will return all the data, all the combination. Cartesian product is not the error. Okay, when you learn this one, there is no error. It's a correct statement, but it will return bunch of the data. Sometimes you should be able to use Cartesian product also. Okay, but mostly, so you and your friend develop the SQL. It's a very, very complicated SQL. Along the 100 line, 500 line. But output is the same. But mine will take my friend SQL learning 5 seconds. But mine is 1 month. Sometimes that's possible. At that time, you should be suspicious on the Cartesian product, whether there is a missing join condition. Like this one. distinct a little bit. So we can utilize also set operation as we learned in the relational algebra model. So we can union. What if we union this one, the first thing, return column should be not same, type comparable. Same number of the column, and it can be E name, it can be P name, there will be no error. But data type should be same, no, comparable. Which means if automatically change it, for example, date can be converted into the character automatically sometime, depending on DBMS system. So you need to check which one will be type comparable in your SQL. But union, anyway, it should be type comparable. Another thing is, for example, first SQL return 1, 2, 3. Second is 3, 4, 5. What will be return of the union? 1, 2, 3, 3, 4, 5. In SQL, not relational algebra. In SQL, what will be the return data? 1, 2, 3, 3, 4, 5. Because SQL allows duplicate data. No. In case of union, it should be unique. This is the only exception. Because union comes from set operation. Set, actually, in mathematics, set is the no duplicate data. So 1, 2, 3, 4, 5 will be returned. So don't be confused. That's really happen a lot. So when you are in real life project. However, sometimes you want to keep the duplicate data 1, 2, 3, 3, 4, 5. At that time you can use the union all. So you can use the union all or even including duplicate data. Union all is different from union. Okay? Nested query. Sometimes we can join the two tables when you access the multiport or the data source. However, when you join two tables, you need to find the join condition. Instead, what if? For example, this query is the same as the previous one. Retrieve the name and address of all employees who works for the research department. First, why don't you search the research department information from one room? Come on. So what is the research department? Take, then bring the data into the next room, then find the employee who works for research department. It's kind of sequential way. So first, access department, research department information, get the department number of the research department. Then run the select outer query, that is the employee who are working for DNO for the 10. At this time, it means set operation like the one of this. Sometimes this is called the inner query. Inner query will produce several data. So DNO in means one of the return data. So this is called nested query. Query inside the query. That's a little bit different from the join operation. This time we do not use the join operation. However, output is same, but different way. As I mentioned many times before, when you access the New York Manhattan, there are a bunch of different ways. You can take the I-95, you can take even the ferry, you can go to the Boston, then take the flight to the JFK. Bunch of different ways. But different thing is performance. How fast is that? So this is another way. This is a correlated nested query. Among the nested query inside the query, you can see the dependent name. Not even ESSN. Actually, ESSN from here. So you can borrow the column name from outer query to inside, or the column name inside to outside, correlated. This one is called the correlated nested query. For example, literally the name of each employee who has a dependent be the same first name as the employee. So for each employee independent, then check for each employee, check the dependents whether the first name are the same or not. This is the data by day correlation. You will practice in the exercise all of this. Or we can use definitely the join operation to combine. Okay? Output is the same, but different way of accessing the data. There are several others set operation like the contains. Contains means output of this one will contain this one subset. Exists is whether there exists data or not. Just checking whether exists or not. The opposite of the exist is the not exist. As I explained before, in is the set operation like that. This is the same as P-NO is equal to 1, or P-NO is equal to 2, or P-NO is equal to 3. One of this. That is the in operation. How can you compare the null data? Can you actually compare the null data? No. That doesn't make sense, because how can you compare? So can you compare the him and the ghost? No, ghost doesn't exist. That doesn't make sense. Okay? So to compare the null data, actually there is no comparison. Instead, you can check whether there exists or not. You can check the existence only. Whether there exists data or not. That is called the null, is null, or is not null. This is just checking existence. This is not the same or difference. No, it's just existence. So SuperSSN is null or SuperSSN is not null. This is only in database query. For join operation, we can use a join such a way, or this is another way to do join, like the employee left outer join, employees on SuperSSN. Left outer join is what? All the data in the left hand side, all employee, then join with the employee, another employee for supervisor. Then if there exists the match data, show. Otherwise, it will be none. So that is left outer join. Here's some other query. Let me have the 5 more minutes. Aggregate function. So we have learned about the aggregate function for statistical function, like the max, mean, employee. So we can use as with the column name. So you can understand easily. The maximum salary employee, minimum salary of the employee, and average salary of the employee. That's it. However, when you are using the aggregate function, like the group, for example, for each department, make the group by department. So at the time you need to specify group by DNO. Group by department. Select DNO, for each DNO, count how many employees and average salary. So first access the employee, then group by department number 1, department number 2, department number 3, employee. Then compute the how many employees for each group and average salary. Then return. At that time, group by should be specified. Very, very important. And also, this group by column should exist in the select, even though you do not want to specify the retrieve the data. You don't know which department. For example, average salary is 1,000. Whose department is that? So you need to specify the DNO here. But however, nowadays most of the modern DBMS, relational database management system, support without this, but basically it should exist both Okay, very important. What if there is no group by? We will consider input as one group. At that time, you don't have to specify. Because it's just one group. So also another group by P number and P name. At that time, we should have the P number, P name, then aggregate function. What if we have the condition for each group? For example, so I'd like to retrieve the count and average salary for each group, for each department. But their employee should be at least one, equal or bigger than one employee department. At that time, condition, because that is the condition, we can use where condition? No, we cannot use where condition for group by condition. Why? First, we need to group, right? Then compute the average salary and count for each group. Then check the condition. So this condition is different from where condition. This where condition will be first time, then group, then check the condition. That is the reason having will be separated. Very important one. So you can test on the exercise lab. Database, relational database model provide very nice fancy the string function. One of the difficulty when you learn the C program, old program, very hard to manage the string data type because there is no string data type. Like the STI copy, it's very hard. So the database you can use such a string comparison. Why don't you read the textbook, then practice while you are doing the practice, try that example. I think it's not difficult, so you can understand easily with the example. It basically provides under, bar, and percent. You will use the percent a lot, like this. This is an option. As long as it has a Houston, tx, it will return all the data. And this is a byte by byte option. And also, I want to retrieve the data ordered by something. You can use order by. Okay? It can support the ascending as well as the descending. Okay? Then this is a complete list of the cross. Bracket means is optional. Select from where group by having and order by. Okay? So I think this class is one of the fastest database course to explain the SQL. Sometimes if you go to the private institution, it will take, I think, at least 2 months, sometimes half a year, but we complete the SQL within almost 70 minutes. Okay? But that is because we already learned the basic of. This is just a language, a very high level language. So the more important thing is whether you understand fundamental and the model, relational model. Okay? So on Thursday, do not come to classroom. For assigned the section, you can go to the exercise lab. As I announced the first beginning of class, so do not copy the homework. It's just a waste of your time. So this is the only time for resubmission. From next time, so I will not accept any the copied submission. It will be automatically flagged. Thank you and see you next class.